Hello everyone. Today I am going to discuss the second problem of AtCoder regular contest 149, which is 2 LIS sum. So we are given two arrays of same length n, A and B. We have to find the maximum possible sum of LIS of A plus LIS of B. But we can do this operation any number of times. So what is the operation? We can swap AI with AI plus 1, I plus 1. If we swap I and I plus 1 in A, then we have to swap similar case I and I plus 1 in B too. So we have to find what is the maximum value of LIS A of plus LIS B after performing this operation any number of times. So let us take the first case, 5 5 2 1 4 3 3 1 2 5 4. So here you can check is that they are first doing this operation I equals to 2. So they will swap 1 and 2 here. So the array will become they will swap this 2 and this 1. So the array will become 5 1 2 4 3. And similarly this 1 and 2 will also get swapped. So the array B will become 3 2 1 5 4. Similarly in the second case they are choosing I equals to 1. So they will swap 5 and 1 here and 3 and 2 here. And at the third operation they are choosing I equals to 4, so they will swap 4 and 3 here and 5 and 4 here. So the final array will become A 1 5 2 3 4 and B 2 3 1 4 5. So for A 1 2 3 4 is the LIS. For B it could be it is 2 3 4 5. So the answer will be 4 plus 4 equals to 8. Now I hope you got the like what is the problem all about, and let's jump into the solution. So the solution is quite straightforward. Here one thing you can observe is that AI not equals to AJ and BI not equals to BJ for I not equals to J. That means all the elements of A and all the elements of B are distinct. So uh, here you can check is that there could be a mapping from AI to BI. So now the solution is quite straightforward. I have already told that we'll just sort the values of A and accordingly we'll change the values of B. What I am telling about. So let's consider the array as A as 1 3 4 2 and array B as 5 3 2 1. So now if we sort the value of all the values of A, it will become 1 2 3 4. Now we will just map from AI to BI here. So 1 is mapped to 5, 3 is mapped to 3, 4 is mapped to 2, 2 is mapped to 1. So similarly we'll change the values of B here. So 1 is mapped to 5, so it will be 5. 2 is mapped to 1, so it will be 1. 3 is mapped to 3, it will be 3. And 4 is mapped to 2, so it will be 2. So our answer will be, as we are sorting the values of A, it will be length of the array. Here it is n equals to 4 4, and here you can take either 1 3 or 1 2. I am taking 1 3, so the answer will be 4 plus 2, which is 6. That is the solution. Now let's come into the proof of the solution, why it is working. So let's say we have sorted the values of A. So let's consider AI comma BI as pair, AI comma BI as pair, and we have sorted according to AI. Okay, as all AIs are distinct, so we don't need any other condition. So we are just sorting this pair based on the first value of the pair. So we have sorted AI comma BI. So let's consider this as AI and this is as BI. Similarly, this is A1 B1. Similarly, this is A2 B2. Let me write it. So these are the pairs A1 B1 A2 B2, similarly AN BN. Now we have already sorted A, so you can already told that A1 less than A2 less than or less than AN. So now we can do this operation I with I plus 1. So if we swap I and I plus 1, the like A1 less than A2, I think you understood the condition here. So if we swap AI and AI plus 1, it might change the one condition, like let's say AI is less than AI plus 1 in our case. So this pair AI and AI plus 1 is contributing to 1 in the LIS, because it is in our LIS. Let's say 1 2 3 4 5. So now this 3 and 4, this pair I and I plus 1 pair is contributing to 1 in our LIS. Now if we just swap 3 and 4, it will our answer will decrease by 1. Okay, I think you got it. So if we just swap 3 and 4, it will be 1 2 4 3 5. So our LIS will become 4 now. Previously it was 5. So what I am saying is that if we swap any of this pair, let's say swapping this with this, then the value of LIS will obviously decrease by 1. It is sure shot. Now, you may argue that if we are swapping B1 with B2, it may have the case that B1 greater than B2, and if we are swapping B1 and this pair, our LIS will increase by 1. Let's say let's consider the simple case 2 1 and 1 2. So if this is the first pair and this is the second pair, now if we are swapping these two pairs, uh, the first pair will now become 2 1 and the second pair will now become 1 2. You may check that the LIS contribution of B is increasing by 1, but similarly the LIS contribution of A is decreasing by 1. So it literally have no effect. So swapping these pairs literally have no effect. So we will not swap these pairs, and this is our desired solution. So for the what is the value of LIS of the like the array A, it will be in, because we are sorting according to the values of A. And now we just have to find the LIS of the array B, so call it L. So our final answer will be n plus L. So for sorting these values accordingly, you can just do this: first sort the values of A and store a mapping from AI to BI, and similarly change the values of B. This is the first approach. And for the second approach, you just store the vector of pairs AI comma BI and sort them accordingly. I have just followed the second approach. So let's jump into the code. Here I have taken the pairs of AI comma BI and I have sorted accordingly. uh, this case, I have just finding the LIS of A and B. This is not required. You can just we only have to find the LIS of B and just do n plus LIS of B. I have already told that. And here it is finding the LIS in login. Let me explain it in a bit. Okay. So let's say our array is 1 3 2 5 4 6. Okay, you will also find it in Geeks for Geeks or any YouTube channel. The LIS in login, you will search that and you will find the video. So let me explain it again. So 132546, we have to find LIS in login. So now we'll just maintain an stack kind of thing and or an vector. So first we'll just put one here. Okay, now when we are at any element 3, we'll just find what is the lower bound or bisect left in Python. So for in this array, let's call it V. So in the array view, we'll try to find the lower bound of 1. So it will point out to, let me just do it in vertical fashion, sorry, horizontal fashion. It will be more easy for you to understand. So first it is now one is being put here. Now for 3, we'll just find the lower bound of 1 in the 3 in the array. So it will give us the second index. So we'll just put 3 here. Now for 2, we'll just try to find the lower bound of 2 in the array. It will also give us the second index. Now we will modify the value of 2 here. So our array will become 1 2 now. Now we'll just try to find lower bound of 5 in the array. It will just give us here this location. So we'll just put 5 here. Now when we try to find the lower bound of 4 in the array, it will also give us this location. Now we'll just modify the value of 5 to 4. We'll just do 5 to 4. Now again we'll try to find the lower bound of 6 here. It will give us this location. So we'll just put 6 here. So our LIS is 1 2 4 and 6. So you can check it, that's what I am doing. In Python, bisect left is similar for lower bound in C++. So if h equals to length of dj, we just appending on p. You can also take n size array. Here I am taking some kind of vector, or else dj of h is equal to p, and at the end we are returning the length of the LIS of a and LIS of b. I hope you got my explanation. If you still have any doubt, you will always ask me in the comment section. Please like the video and subscribe to my channel. Thank you.